derivatives of exponential functions. So let's jump into it. So first off, let's find the derivative of the general exponential function f of x is equal to b to the power of x using first principles. So remember, before we get going here, b could be any number, 2, 3, 5, whatever. Okay, so let's take the limit as h approaches 0 of our first principles formula like we've done before. So this would be f prime of x is equal to the limit as h approaches 0 of, and then this would be b to the power of x plus h, right? So we're filling in, right? This is f of x in here, right? So in that case, it's whatever's in the exponent. So b of x plus h. Okay, minus b of x, just the original function, over h. Okay. So now let's write this a little different. So we'll say this is equal to the limit as h approaches 0. Now b of x plus h, I'm going to write this as b to the x times b to the h. Do you see how that's the same thing, right? Just using our exponent laws? Because that could be written itself as b to the x plus h. You'd add the exponents, right? So I'm just kind of going the other way. Okay, so it's that minus b to the x over h. Now, so the limit, I'm going to factor out a b to the x. So we've got b to the x. And then what's left is b to the h minus 1 all over h. Now, the next step here, I am going to just pull this b to the x just out front. And why can I do that? Well, I'm taking the limit as h approaches 0. There's no h in that. So it's fine to just pull that piece out. So this would be b to the x times the limit as h approaches 0 of b to the h minus 1 all over h. All right, so that's a good starting point. And remember, this is what f prime of x is equal to, right? So this is what the derivative would be equal to. So we've kind of got the beginning of a formula. So it's going to be, so the derivative of b to the power of x would be b to the power of x times something, right? So let's kind of figure out what that something is. Now, b could be different numbers. So let's see what happens when we throw different numbers in for b. So let's say 2 or 3 in for b there, right? So as h gets ever closer, right? So from the right and then from the left of 0, like we would do before, right? So approaching it from the left, approaching it from the right. Let's see what number we get close to. Well, we get really close to 0.693 on both ends. Okay, so that's what happens if you put 2 in. Now if you put 3 in, we get 1.099, 1.099. So we're approaching that number. Okay, what's the significance of that? Okay, we'll get there, I promise. So now, in this case, if we just kind of put that back in for a second, so when we had 2 as our b value, then the derivative of 2 to the power of x would be, well, remember this b to the power of x was just sitting out front? Okay, well, so then that would be 2 to the power of x times, and then in this case it was 0.693, or approximately equal to that, right? Okay, and then that would be the derivative of 2 to the power of x. We won't have to do this every time, I promise. But for now, we're just working on something. So now the next one would be 3 to the power of x times, and then the limit, like all this chunk, right? When it was 3. So that would be 1.099. All right. Now, let's find the natural log of 2, just plugging it into your calculator. So just lowercase ln 2. So what do you get? The natural log of 2 is approximately equal to 0.693. Hey, that's that. Okay, so let's do the natural log of 3. So the natural log of 3 is approximately equal to 1.099. And that's that, isn't it? Okay, I think we're there. So this really is, yeah, that number with a natural log, right? So we can say the limit of, as h approaches 0, of this chunk, right, would really be the same thing as the natural log of b. Perfect. Because then now we can put this back in, remember, all the way back up here. Remember, it was b to the x times the limit, right? Okay, so then that means that we have a formula. That the derivative of b to the power of x would just be b to the power of x times the natural log of b. There you go. Now, what if the base b is e? Okay, well, e is the opposite of the natural log, right? So if you kind of go back a little bit, we talked a little bit about this in Math 30-1. So the natural log of e, if you remember, is equal to 1. And that's really for the same reason that, let's say, log base 3 of 3 is equal to 1, right? It's like the same thing. This natural log of e is really like saying log base e of e, right, is equal to 1. Now remember how this works. This is really saying e to the power of 1 is equal to e. Log solve for exponents. Okay? So either way, the big concept here is that the natural log and Euler's number, e there, are opposite operations. Okay, so let's apply that now. So what if the base b is actually e? So let's say the derivative, so d dx of e to the power of x is equal to e to the power of x times the natural log of e, okay, which is really e to the power of x times 1, right? Because those just kind of undo each other, just equal 1. So then in the end, the derivative of e to the power of x is really nice. It's just e to the power of x. Perfect, right? That's probably the easiest derivative we have. Well, it's definitely the easiest derivative. Okay, so in general, let's just write that one more time. The derivative of e to the power of x is just e to the power of x again. So now this also gives another way to define Euler's number, or e. We can say that the limit as h approaches 0 of e to the power of h minus 1 over h is equal to 1. Okay, you guys won't be required to, prove what Euler's number is or anything, but yeah, that's just another way to do it. So, okay. So when taking derivatives of exponential functions, we do have to use the chain rule. So the chain rule. Okay, so whenever the exponent is anything other than x, so if you had something like this, right? So if you had derivative of e to the power of some other function, g of x, then we'd have to write this as e to the power of g of x times g prime of x, times the derivative of g of x. Okay, let's jump into them, because to tell you the truth, I don't think you guys are going to find this that bad. So let's take the derivative of f of x in this first one. So we've got f prime of x is equal to, all right, so well, that negative 8, you can actually just pull that out for a second if you want, right? The negative 8 just hangs out front. And then the derivative of e to the power of 5x is really nice. It's just e to the power of 5x. Perfect. But then don't forget, right? We have to take the derivative of the exponent there as well, right? Like the inside of the chain rule. So derivative of 5x would just be 5. So that's equal to negative 40 e to the power of 5x. And done. All right, next one. Okay, so y prime would be, well, okay, e to the power of cos x. I know that one. That's just e to the power of cos x. Nice. And then times the derivative of cos, which is negative sine. And then there you go. Maybe put the negative sign up front. So negative sine x, and then times e to the power of cos x. Okay, so now f of x is equal to, all right, careful on this. I don't see an e, right? So I can't just say that it's the same as the derivative, or the derivative is the same as the original function there. This one, I have to use the first one there. So this would be 6x to the power of 4x cubed, right? This is just like my b to the power of x part of the first equation. And then remember, it was b to the power of x times the natural log of b. Okay, so that's, we just have to do that part now, right? So times the natural log of, and my b was 4, or sorry, my b was 6. So natural log of 6. And then don't forget though, so that was taking the derivative of, you know, the outside of my function. Now we still have to take the derivative of the inside. So the derivative of 4x cubed would be 12x squared. Okay, and then just kind of clean it all up here. So then we've got, so it'd be negative 12x times the natural log of 6 times 6 to the power of 4x cubed. Just really wrote it in a different order, but oh, forgot my squared there. Oh, and that was the derivative. Okay, forgot a few things. Okay, next one. Okay, so y prime of this guy. Well, first off, first step's really easy, isn't it? It's the derivative of e to the power of x, right? When this is my x, is just the same thing written again. So e to the power of sine squared x to the power of 3. And then I'm just going to move on from there. So now the inside of my function, I'm just looking at this one. Now careful on that though, because right, this squared, that's the outside of my function, right? Because this is really, you know, that. It can be written that way as well. So just keep that in mind when we do this, because now we'll go, okay, times, and then this would be 2 times, and then just sine x cubed again. I'm just bringing that exponent down. So that's sine x cubed. And then now that we've done that, right, now we got to take the derivative of the inside, which is sine x cubed. So then that would be cos x cubed. Okay, and then we're not even done, because now we got to take the derivative of that last inside, like the very last one. So x to the power of 3, the derivative of that would be 3x squared. Okay, putting it all together, we get 6x squared times e to the power of sine squared x to the power of 3 times sine x cubed times cos x cubed, and done. Okay, so now we have a product rule example. So f prime of x would be equal to, and then that would be, okay, so if this is my f and this is my g, then this would be, okay, the derivative of f, we'll say. So actually, sorry, the derivative of, I'll just do f and then derivative of g. So written. So that'd be 6x to the 4, and then, so that was f, times the derivative of g. Well, that's easy. That's e to the power of x, right? So that was g prime, plus now the derivative of f, which would be 24 x to the power of 3, and then g, so e to the x again. So this was my f prime, and that was my g. Now it looks like I could factor some things out of this. So looks like I can factor out an e to the power of x, and then 6x to the 3. So 6x to the 3, and then what I'd be left with would be x plus 4. All right, now a quotient rule example. So we'll do y prime is equal to, so this will be my f and that'll be my g. So g, which would be just writing 1 plus x squared, again, right? So that's my g. And then f prime, so e to the power of x, minus, and then f, which is e to the power of x, times the derivative of g, so 2x. Okay, so that was f, and that was g prime, and then that's all over 1 plus x squared squared. Okay, so I'll factor out an e to the power of x in the numerator there. We've got e to the power of x. Actually, no, I better show this next step. Let's expand that e in, right? So we've got e to the power of x plus e to the power of x, x times x squared, minus e to the power of x. Here, I'll go 2x times e to the power of x, all over 1 plus x squared squared. Okay, and then now I'll factor out my e to the power of x, and we've got 1 plus x squared minus 2x all over 1 plus x squared squared. And then lastly, if we factor this, then we get e to the power of x, and that would be the same thing as x minus 1 squared, right? It's a perfect square, over 1 plus x squared squared. And there you go, that's what y prime was. Okay. So now we'll derive this one using implicit differentiation. Okay, so the implicit differentiation, we're just taking the derivative of each of these terms individually. So we'll say e to the power of y, right? So the derivative of e to the power of y is just e to the power of y. But then don't forget, we have to multiply that by y prime. Okay, just using that, that's the implicit differentiation part. Okay, and then for the next one, so we have to think about this as f and this is g. So this will be x times 2y and then times y prime. So going back, this was my f and this was my g prime, right? I had to take the derivative of x or y squared, which is 2y, and then also chain rule in the y prime with it as well. Okay, and then plus, and then it'll be g, so that would be y squared, and then the derivative of x, so just 1, right? So that was my f prime, and then plus, and then the derivative of e to the power of negative x squared. Well, we always just write it again pretty much, right? And e to the power of negative x squared, and then times the derivative of the inside there is, again, so times negative 2x. Okay, so I need a way to get my y primes, or my derivative of y, on the same side. So we'll just write e to the power of y times y prime minus, all right, with a number up front, 2x y prime is equal to y squared minus, and then e to the power of negative x squared. Okay, next step is we're going to factor out our y prime. So we got y prime, and then we're left with e to the y minus 2xy is equal to y squared minus 2x e to the power of negative x squared, and then we'll just divide both sides by this chunk. So we get y prime is equal to y squared minus 2x e to the power of negative x squared all over e to the y minus 2xy. All right, and there's our answer.